Hey, grade 11 chemistry students. Today what we are learning about is how to identify different types of chemical reactions: synthesis, decomposition, single displacement, double displacement, and combustion. And we're also learning how to write balanced chemical equations. So this is a new unit. It's probably going to be about 2 weeks. The title of the unit is Chemical Reactions. So we're going to be doing a couple labs to experiment with different types of chemical reactions, but we're primarily focusing on balancing and determining what type of products form. In today's lesson, though, again, we're just classifying different chemical reactions, and we're learning how to write balanced word equations. So we will see if we can get to classifying, but we're definitely learning how to balance today. Okay, because we are talking about balancing first here, we have to know something about the law of conservation of mass. If you start with a certain amount of products, you will end with the same amount of products. That's basically the law of conservation of mass in my own words. The mass of the reactants is equal to the mass of the products. Atoms cannot be created or destroyed. You are not God. When you do a chemical reaction, you cannot create or destroy atoms. The amount that you start with is the amount that you finish with. They can rearrange, form bonds, and do different things, but you cannot create or destroy them. Thus, the mass of the reactants equals the mass of products. So when we balance chemical equations, it reflects the law of conservation of mass. In other words, we will have the same number of each kind of atom on both sides of the equation. If you have an arrow, that means reaction, and that means the atoms on the left side of that arrow will equal the amount of atoms on the right side. So we have a couple rules for balancing. So the first thing that we have, first rule is we write down the equation unbalanced using formulas. For example, if I give you a question that says hydrogen gas plus oxygen gas equals water, what you'll have to do is write down what we call the skeleton equation, which is just the chemical formula. So you can see here I wrote down the skeleton equation, which means it's the unbalanced chemical equation: hydrogen gas plus oxygen gas equals water vapor. So now I've given everybody a state. This is unbalanced. It breaks the law of conservation of mass because I have two hydrogens, good, here, but I end with two hydrogens, good, that's good. I wasn't God there. But I started with two O2s and I finished with one. If I truly did this reaction, if I had one H2, one O2, and one H2O, I destroyed one oxygen. That is impossible for me, and it breaks the law of conservation of mass. It is a skeleton equation. It's unbalanced. So next what we do is we write down the number of atoms that are on both sides of the equation. Like so the product side, which is the right side of the arrow, and the reactant side. Reactants means it reacts, it goes in. So we have to add up the total amount on each side. To do that, well, what I do is I just write down an H and I write an O and I write H on and an O on both sides. You can see I have two H's on this side. I have two O's on this side. On this side, I have two H's and on this side, I have one O. So product side has one less O compared to the reactant side. It's unbalanced. Okay, next step, what we have to do is we have to change the coefficient on the side that has less. So obviously on the product side, I have one oxygen compared to two, so I'm going to fix that first. The coefficients are the number that goes in front of the chemical formula. In this case, it's 1, 1, 1. I'm going to change this to 2, and that just acts like multiplication. 2 times the 1 here is 2 here, so I've balanced it. But in the process, I've changed the amount of hydrogen, so that is now 4. So you can see I now have another unbalanced problem here. I have hydrogen is unbalanced, so I have to fix that next. Okay, so since I upset this hydrogen, I want to balance the atom you unbalanced. That may seem strange to you, but what I mean is we mess up this hydrogen, so we want to fix this other hydrogen. So what coefficient can we put in front of here that's going to get multiplied in there to equal 4? Well, the answer is 2. So 2 times 2 is 4. So the coefficients that go in front of this are 2, 1, 2. And we start with the same amount of atoms as we finish with. We have 4 hydrogens to start. We finish with 4 hydrogens. 2 oxygens to start and 2 oxygens to finish. Now, there's a couple other rules that we want to know when we're balancing. I'm going to write them down now, and we'll discuss them briefly. Next rule that's good to remember when balancing is you want to count polyatomic atoms instead of individual atoms. So when I shouldn't say atoms, I should really call them ions because they are ions. So you can see that phosphate is present here. I'm not going to count 1P and 4Os. I'm going to count just phosphates because I can see that I got phosphates on both sides. That's one phosphate here, one phosphate here. Keep that in mind when you're balancing. Next rule we have is balance the most common atom polyatomic ion last. What I mean by that is if you look here, carbon is found here and here. Oxygen is found here and here. Oh, and it's also found here. And hydrogen is just found here and here. So you can see that oxygen is actually found in 3 places. So we would want to balance carbon first, hydrogen second, and then oxygen we want to kind of do last. So that kind of creates a difference in our procedure that we do. So sometimes if you end up with a fraction, you have to multiply to eliminate. Some special cases when you balance, you actually end up getting a half. Now to eliminate that half, what you have to do is you multiply everything by 2 because 2 times 7 is 14. 14 divided by 2 is 7. So if we multiply everything by 2, what we would end up getting is we'd have 2 here, 7 here, because 2 times 7 is 14 divided by 2 is 7, and 2 times 2 is 4, and 2 times 3 is 6. So you can multiply a number into each one of these, and you want to have the lowest balanced thing. So if I had, again, 4, 6, 6, 2 in my balancing, remember you can also reduce that. You want the lowest possible. So it would be 1, 3, 3, 1. So let's do some specific examples here now. So if we look at this top example, we have SO2 plus O2 equals SO3. We have 1 sulfur here, because there's a 1 here, and there's a 1 sulfur there. There is oxygen's difficult here. You have 2 here, so you actually have 4. And again, we have 3 oxygens here. So when we look further at this example, sulfur is balanced, so we have to balance oxygen, but you can see that it's found in 3 of these compounds here, or atoms, and we want to make sure that we're going to balance that. So we look at that and we say, oh boy, so I have to increase this side. So I'm just going to increase it to 2 and see what happens. And 2 times 3 is 6. 2 times 1 sulfur is 2. All right, so that's okay. Let's take a look at that. So I've kind of increased, so I have to increase my oxygen side, but I'm going to fix my sulfur problem first. So I'm going to put a 2 here. 2 times 1 is 2. And 2 times 2 is 4, so I have 4 oxygens from just there, and don't forget these 2 oxygens. So the answer is 6, so this is the balanced chemical equation, 2, 1, 2. So let's look at our next example here. We have, look at this, oh, I have a polyatomic ion here, and I have a polyatomic ion here. It has not changed, it's nitrate on both sides. And I'm also going to count hydroxides. It's going to make it a lot easier if you balance it, the polyatomic ions. Okay, so I wrote down all the polyatomic ions. I'm going to count them now. I have 1 copper on this side. On my product side, I also have 1 copper. I have 2 nitrates because that 2 gets multiplied in there. On this side, I just have 1 NO3. On this side, I have 1 potassium. On the other side, I have 1 as well. I have 1 hydroxide on this side, and I have 2 on this side. So you have 2 options here. Copper is good. Potassium's good. I can either pick on nitrate or hydroxide. The same thing's going to happen. So let's watch what happens when I just pick nitrate. I have 2 nitrates on this side and 1 nitrate here. So I'm going to put a 2 in the front. I can only change the coefficient. I can't put a 2 here. That upsets my actual chemical balancing of the ions. So if I put a 2 here, I now have 2 nitrates, but I also have 2 potassiums. So let's go after what I messed up. I messed up my potassiums now. So I'm going to try and fix my potassium problem. Change the coefficient to 2 here. That's good there. Perfect. 2 potassiums. But now look, I've upset the amount of hydroxides I have. I actually have 2 hydroxides. But if we take a look, we are balanced. And that's as easy as it is to balance. Let's try one more quickly. Okay, let's look at this example. In this example, we're asked to make a skeleton equation because we're given the chemical name. So we have to come up with the chemical formulas. So it says write the equation for the reaction of tetracarbon decahydrate gas. So I'm just going to write that down because I know it's reacting with. So it's C4H10 gas plus oxygen gas. And what it's producing is carbon dioxide gas and water gas. So let's go ahead and quickly just count how many atoms we have on both sides. Okay. So quickly, I have, oops, sorry about that, 4 carbons. So I have 4 carbons on the reactant side. I have 1 carbon on the product side. I have 10 hydrogens on the reactant side, and I have 2 hydrogens on the product side. If we look at our oxygen, which is found in 3 places, we're going to want to balance that last. That has 2 on the reactant side, and it has 3, 2, 3 on the product side. So in this case, what we're going to want to do is we're going to want to do oxygen last. So let's balance everybody else first. So I'm going to balance my carbons first. I have 4 carbons on this side, so I'm going to put 4 on this side. That changes that to 4. It changes the amount of oxygens I have. I'm going to worry about that at the end, though. I have 10 hydrogens on this side, 2 hydrogens on this side, so I'm going to put a 5 here. 5 times 2 is 10. Now let's count out my oxygens where I've changed this. So 4 times 2 is 8. And 5 times 1 is, so I have 8 O's here, and I have 5 O's here. That's 13 O's. Oh boy, that's difficult because I can only put an even number here. If I put 1, it's 2. If I put 2, it's 4. But I got to put 13 here, and I can only add by even numbers. So what I'm going to do is something strange here. I'm going to put 13 here. We know that 13 times 2 is not 13, it's 26. But 26 divided by 2 is going to be 13. So I've actually balanced it out by writing this. In the future, it's okay that you balance this, but what did I say about removing the fraction? You multiply everything by 2. So 1 times 2 is 2. 13 halves, or 6.5 times 2 is 13. Just get rid of that bottom part. 4 times 2 is 8, and 5 times 2 is 10. If we add everything up, what we will get is 26, 28 on both sides. We are balanced, okay? And this is how you balance it. For tomorrow's class, please do this. You are going to try and create a balanced chemical equation from the following reaction. So write the skeleton formula first, go through the steps. If there's polyatomic ions, please try and balance them. Anyways, look forward to seeing you tomorrow for a brand new unit.